For the first problem right here, our domain is pretty straightforward because you have from here to here, and then you have this part of the function from here over to here. So we can write that as, since we have an arrow on the far left side of the function, that's going to be negative infinity. Make sure you use parentheses and not a bracket, since infinity cannot be defined by a number. And that will go to a positive 4, and you're also going to use parentheses because you have an open circle on that 4 right here for your x value. And that's combined with, now here you can use a bracket because this x value can be 4. And it has a definite stopping or end point at a positive 7, and since it's a closed dot, you can also use a bracket there. Now the range for this one I'm not 100% sure on, because this part of the function is completely separate from this part of the function, so we have to have a stopping point. So what I'm going to say is the part of the function down here would just be -1, since that's a constant y value for that part of the function. There is no actual range. It's just a horizontal line at -1. And it can equal -1, so I'm going to put brackets there. And then that's also combined with a positive 1 with an open circle, so we're going to use parentheses. And that can go up to infinity since we have an arrow at the upper end of our graph. And always use parentheses to define infinity. This next one is another one that I'm not 100% sure on. Obviously, for the left side of the graph, for our domain, we would have a negative infinity because we have an arrow, it can't go on forever. But we have the stopping point down here at -5, and it can't equal that. So this part I am pretty sure on. We have parentheses to indicate negative infinity. We're going to -5. Use parentheses there also because of your open circle. And then this is where there is a stopping point over here, but since it's a closed dot, I'm not entirely sure that we would need to recognize that with our domain notation. So I'm just going to say we can go from -5 with a parenthesis all the way to a +3. But again, I'm not 100% sure whether we need to recognize this point, this end point on x equals 1 or not. So again, we have -5 with parentheses ending at -3, and it can equal, or +3, and it can equal 3, so we'll use brackets there. Okay, this is another part for this problem I'm not 100% sure on. We have the range. The lowest point is -5, but then you have over here where it can equal -5. So I'm going to treat this as two different parts of the function. I'm going to treat this as one part of the function and this as a second part of the function. So I will say that from -5 is our lowest value. It can't equal -5 on the first part of the function. And it can go all the way up to infinity because we have that arrow there. And then we have -5 is our lowest point. It can equal that at this point because it is a closed circle. And then for this part of the function, again, since I'm defining it from here to here, our highest point is 0. I'm not going to say this is our highest point because I'm using this whole section here. And it does fall on the 0, so I will use brackets for that also. For your next set of problems, you have the directions to find the y-intercept by looking at the graph and then to find it and demonstrate it algebraically. So I'm going to show you both ways. Obviously, the y-intercept is when your graph crosses the y-axis. And with this graph right here, since it looks like a portion of a parabolic curve, there is no y-intercept just by looking at it. So we're going to go ahead and prove that mathematically over here. To find the y-intercept, you always set the x value to 0, because when it crosses the y-axis, x will always be 0. So you just go like this, f of 0 instead of f of x, and we're going to replace x with 0. Then f of 0 simplifies to being the square root of -1. And this is where I'm not sure if you learned this or not yet, but the square root of -1 cannot be defined by a real number, so we use it as I. The square root of -1 is always I. Essentially an imaginary number. So then you have f sub 0 equals I. Since I cannot be defined by an actual or rational number on a graph, actually it's not a real or rational number, there is no y-intercept here. But for your other problems, you can tell where the graph crosses the y-axis just by looking at it, and then if you need to prove it mathematically, always set your x equal to 0 and then simplify the problem and go from there. Since your last set of problems asks you to determine whether each graph is symmetric to the x-axis, y-axis, or origin, I'll just go with the first example that we're given here. Now just by looking at it, I can tell that this is symmetrical to everything, but we will need to prove it and we'll need to show it mathematically or algebraically. So I'll go through each test. We'll start with x. In order to test whether something is symmetric to the x-axis, you set the y value at its opposite value. So instead of saying we have y, we're going to have it as -y. So I'm going to write out our original equation that we're given. We have x squared plus 4y squared equals 16. And what we do here, we'll just say this is the test. You have to make it the opposite. You just have to make sure it works on both sides of the x-axis. So what works up here on a positive y value should also be symmetric to what's down here. And so when we get to the x, what works over here should also work over here. And that's why you test the opposite value. So our x value stays the same, and this is weird. Just remember, when you're testing the x-axis, the y value gets turned opposite. When you're testing the y-axis, the x value becomes the opposite. So you just make that -y squared. And then you have to simplify it. And some of them are going to be more complex than others. This one's a pretty easy one to simplify. Your x squared stays the same. And whenever you have a squaring of a negative value, it's a positive. So -y times -y is positive y squared. So what you look at is you look at your original equation, and then you look at your simplified test equation, and since these two are equal, all of your values are the same, then this is symmetric to the x-axis. So I'll just put a check there. Yay, it's symmetric. Okay, now to test for the y-axis. Write your original equation, always do that. And we are going to set our x value now to the opposite. So we started with our positive x value. Now we want to make sure it works over here. All right, so then our test will be -x squared plus 4y y squared equals 16. And then we simplify it. Negative x squared will just be x squared plus 4y squared equals 16. And since our original equation matches our simplified equation, that means our equation is symmetric to the y-axis. Now finally, to test the origin, you make sure both tests check out simultaneously. All that means is you're going to put in an opposite x value and an opposite y value in the same thing to make sure that your simplified equation comes out the same. I know that sounds confusing, but it's actually pretty easy. So we'll go ahead and do our origin down over here since we're running out of room. So our original equation, x squared plus 4y squared equals 16. Our test, we are going to do negative x squared plus 4 times negative y squared equals 16. And then to simplify it, negative x squared simplifies to x squared. 4 times the negative y squared is just 4y squared and equals 16. So it looks like by doing that, even with putting in the opposite x value and the opposite y value, we still get the same equation that we started with. So that means we are symmetric to the origin. So just to make a couple notes quickly. For x-axis, we're just going, for lack of better words, I'm going to write plug in negative y value. For the y-axis, you plug in negative x value. And then finally, for the origin, you have to simultaneously plug in both opposite of x and opposite of y values. So that should help you complete the rest of the problems. As I said, the other ones might be a little more complex to see and to simplify, but this should give you a good start on how to do it.